Hello there guys, welcome to Yo Sakura. This is a crash course video in which I'll show you how to create 3D composites inside Nuke. So to begin with, I'm going to show you different settings involved when you're working within 3D environment in Nuke, and then I'm going to introduce you to the different nodes involved when setting up a complete 3D scene. Once you're familiar with creating a 3D scene, I'll show you how to render it out as a 3D output, and then in the end I'm going to show you how to create this output. Last thing to note before I get started, this video is about creating 3D scenes and 3D composites. It's not about creating stereoscopic outputs. So for those of you who are interested in that, I'll be creating a video later on, whereas this is definitely not it. So with that, let me just get started with the 3D settings involved while working in Nuke. To begin with, let me show you how to navigate in 3D within the viewer. So once you have a viewer created, by default you are working in the 2D viewport, whereas to work with 3D, we'll just come over here and shift it to 3D. To toggle between 2D and 3D, you can use a shortcut of pressing the tab key on your keyboard to shift between them. Now, as you can see, it didn't really change a lot. It just changed a little bit about the how exactly it was fit into the viewport, and apart from that, the only other change you can see is that there is a 3D axis down at the bottom left corner of the viewport now. By pressing the tab again, I come back to 2D, and by pressing the tab again, I'm back in 3D. So this is the only difference which is occurring right now, whereas there is no actual element in here which makes it look like it's in 3D. So the first shortcut I'm going to show you is how to zoom back with your camera. So here I'm going to just use my scroll wheel and start zooming outward. So once I've done that, you can see that there is a three-dimensional grid which is present here, but what I want to do is actually navigate around in this grid. So if I press Alt and my right mouse button, you can see I can orbit around in this view. So this is one way of moving around in your 3D scene. So this is one of the most important things that you'll keep looking and doing, because you'll have to look at your scene from different angles. So apart from this, you can hold your Alt and your Shift with your left mouse button to pan around. So this is moving the entire scene sideways or top to bottom. Now you already know the middle mouse scroll to zoom in and out. So these are the three most important navigations which you would use when working in 3D. For those of you who are coming in from a different package, like let's say Maya Max, so for those of you, you can go into Edit, Preferences, and go into the viewer preferences here at the top. So when using viewer preferences, you can see the 3D control type is by default set to Nuke. This is the navigation which I just showed you, whereas if you're familiar with other packages like Maya, Houdini or Lightwave, you can set it to the particular package and immediately the entire navigation scheme changes, and you can use the similar navigation. Like I've just set it to Maya, so my Alt left click orbits around, middle click pans around, and right click zooms in and out. So whichever one you are comfortable with, you can set it to that. I'm more comfortable with Maya, and I don't want to relearn the different navigation systems for each software, so this is much more useful for that. So this is how to navigate around in your 3D view. There are other settings, as you can see, when we come into 3D. So we have the 3D background and foreground, which is set. So if you are not comfortable with the black background, you can change that one here. So apart from this, the last 3D setting you have to complete will be in the viewer itself. As you know, we can come to the node graph, and pressing yes on the node graph opens up the settings for the project, whereas if you press the S while you are on the viewport, you open the viewer settings, and in viewer settings you have a 3D setting tab completely set, and here you can set in all the options which you want for this 3D setup. The default settings here are perfect. You don't actually have to edit anything at all, whereas one thing you might want to turn on is headlamp if you have 3D objects and you have to navigate around and they're like dark and things like that. For people who are coming in from exercise, they'll be more familiar with this. So this is how to navigate around. Let's see how exactly you can work with 3D nodes next. Before I actually show you how to create 3D nodes inside Nuke, let me give you a brief presentation which is going to demo how a 3D scene in Nuke can be constructed, the different elements involved, and how to render it out. A scene within Nuke is nothing but a collection of objects that have to be rendered out together. So for example, let us consider a tabletop with a lot of pens and pencils, books and whatnot. So if these are different 3D objects that I want to be rendered at the same time, then these form the parts of my scene, elements in my scene. So let us have two elements in the scene, 3D object 1 and 3D object 2, and now I want to render these two elements out. Now in our tabletop scene, let's just consider this to be one to be a pen and another to be, let's say, a book. So once we have these elements, what we want to do is actually render them out. So inside Nuke, we have a special node which is going to take this 3D scene and render it out as a sequence of images. So that node is known as the 3D renderer or the scanline renderer. So we connect these 3D objects to the scene, which are then become a part of that scene, and then it's rendered out. But there is a problem now. The problem is I don't know which angle the scene has to be rendered out from, meaning the computer does not know this. So because of which, it'll just give you a blank slate. Let's say I want the computer to render the scene from the top view or the front view or the side. If I know this, then I can create a camera which is going to represent the three-dimensional coordinates for the rendering. Once I have a camera set up, I can connect that to my renderer so that my scene is being rendered through that camera. So this is the most simplest setup which you can have inside Nuke for a 3D scene. Now, to take this one step further, because it is a 3D scene, one element which is missing here is lights. The reason we want lights in a 3D scene is because a 3D object looks three-dimensional, not only because of the perspective, but also because of the three-dimensional shading which it gets. Because when a light falls on an object, it gives you the shading. So because of this, the object looks three-dimensional, and that is what we are trying to replicate. So because of this, I want the scene to be lit. So I can create a light and connect it to my scene, so all the objects immediately start interacting with the light. Now this is the most default scene which can be present with all the elements involved. So we have objects, lights, cameras involved in one single scene inside Nuke. So let's get into Nuke and create a simple scene like this, and then I'll come back to the presentation and continue along. All the nodes involved in creating a 3D scene within Nuke can be found under the 3D menu. And one thing to note, all the 3D nodes are always circular or capsule shaped, so it's easy to differentiate them from other nodes. So here, let me start by creating a scene. So this is my three-dimensional scene. As you can see, it's circular in shape, and I'll connect it to my viewer, and you can see immediately a grid is visible. So also my viewport is shifted to 3D. Now once it is connected, let me start by creating a simple object. So I'll first create a simple tabletop. As I was talking about, I'll create a simple desk. So for that, I'm going to take a cube, and a cube is created, and I can navigate around and see this. Now one thing to note here, even though I'm looking at this scene, as you can see here, the input is set to scene, I'm able to look at the cube only because the properties of the cube is open in the properties panel. This is something you have to take care of, because when I close the properties for the cube, you can see it's invisible. If you want it visible in the scene, you have to connect it to the scene. Without it being connected, it will not be visible. So just make sure that the properties panel, even if it is empty, you can see your objects, or else there is some problem and you have to correct it. Now once I have created the cube, I need to change some values so that I can actually go about and start editing this. So with the cube selected, I already have my transforms on the cube visible. So as you can see, there are these dots which I can pull about to scale the cube, or I can use the gizmo in the center to move the cube, or if I hold my control key, I can see there is a new gizmo. It's kind of hard to see, but there are these circles around the arrows, the axis, through which I can rotate my cube. So this is the way I can start transforming the cube within the viewport. Or the easier method is to actually use the properties for the cube itself to start doing these. So to start with, I'm going to start by setting up the cube height to be a lower value. So I'm setting the top part of the cube to a low value on Y. Next, instead of going to the bottom, I can actually edit the value here itself. I can select some value. I can use my scroll mouse or scroll wheel on the mouse to actually lower or increase the value. So I've set this bottom part of the cube to be on the grid, and the top part of the grid to be 0.2, let's say 0.25 units high. So I have this set up, and this is going to be my tabletop. Now, once I have a tabletop set up, let's say I wanted to create a simple book on top of this table. So to create the book, I'm going to create a new cube. So I can go under Geometry, Cube. And this cube goes into the same scene. Remember that if it's not connected into the scene, it's not part of the scene. So once it's connected to the scene, what I'm going to do is keep it on the tabletop. So I'll start by decreasing its size interactively. I'm just going to make sure the value for y here is 0.025, just the same as the height of the table, so that it's exactly touching the bottom of the table. So once that is set, I can also move the entire object by using the translate values here. So I'm going to move the object in x-axis. Okay, sorry about that, it went a bit too far. So I can scroll with the mouse so that I can move the object anywhere I want. I can use the z-axis to position the object somewhere near the center, and I'm going to rotate it on y-axis to give it some, let's just say, to give it some randomness. So this is my book, which is kept on the table. So as you can see, it was very easy to set this thing up. But once it is set up, we have to render it, and before we render, we need a camera. So to set the camera, I can come to the same 3D drop down, and I have a simple cam. I can open that up, and as you can see, again, it's a circular node, and even the objects are rectangular capsulated nodes, rounded edges. Now, using the camera, I can go ahead, set the translate rotate values till I get it to an exact position I want. I'm just going to move the camera back and up, and I'm going to rotate it downwards so that it's looking at the table itself. So now I have the camera looking at the table. If you want to look through any light or objects which are there in the scene, you can go to the drop down list and select the object that you want. By default, only lights and cameras can be looked through, not objects like you can do in Maya. So if I select camera here, you can see that this is the actual object, or this is what I'm looking at. So if I start navigating away, you can see that I'm out of the camera now. If I want to be always locked, I can turn on the lock. So it's always locked to the cam. Also, another thing you have to note here is that once it's locked, the camera is locked, you can no longer navigate in 3D. It's just a two-dimensional panning that you have now. So once your camera is set, make sure it doesn't really matter if your camera is not connected into the scene, because it will not be used. You have to make sure that your camera is connected to the rendering. So once I have my two cubes and my scene set up, I'm going to connect this camera into my renderer. The renderer is also available in the 3D drop down. It is the last node which you get. So this is a scanline rendering. I'll take this, and this node has specific inputs, as you can see here. So the different inputs you have is the camera object, which you need to connect to the camera. So I'll connect this to the camera. Next, you have the object or the scene. So it's not always that you need a complete scene to create a rendering. You can also render directly using an object and the camera if it's a single object. But since we have two, we are going to connect it to my scene. So once it's connected, this rendering is set up. But let's just say that you want to use a background element. I'll talk about a background element in a second. So the background element basically means this empty region which you have in and around the actual table itself, this alpha region. If you want any kind of image to be put into that background region, you can connect it to the background node. We'll be using it later on when we do the composite for the earth and all that. So I'll connect it to my viewer. But as you can see, there is nothing which has changed. The reason for that is because we are still in 3D view. I'll change it back to 2D, and immediately this is what you get. There is absolutely nothing. The reason there is nothing is because there is no light. Everything is basically blank. So I need to create a light in my scene so that I can see what's happening. So I'll keep it exactly the way I had kept it in my presentation so that you can understand it. So I'm going to start by creating a light. I can go into my 3D drop down. I have different lights. I'm going to use a direct light so that it's easier to see what's happening. So once a direct light is created, I'm going to connect it into my scene itself. Now once it's connected, let me go back into my 3D view and see what's happening. I'll turn off the camera lock, and now if I move around, you can press F on your keyboard if you want to zoom into something specific. So as you can see, the direct light is actually sitting inside the cube itself. That is not the issue. The issue is that anytime you're lighting the scene, it has to come in from an angle, especially when you're lighting something like a cube, so that you get more of a variation. So for this, I'm going to press Control, just rotate it a little bit so that there is some three-dimensional variation in the lighting. So let's just say I keep it as such, almost similar to the camera, but not exactly. Okay, so what you have is this 3D look which you're getting now just because of lighting it. I'll come back to my default node. So here what I now have is a complete blank canvas, and as you can see, if I move my mouse around, you can see that there is no actual color value which is coming in. The reason for that is because these are definitely 3D objects, but they actually have no color which is being put into them. So just to get some variations, I'm going to go ahead, create a checkerboard, and just directly plug it into the image inputs for the cubes. I'm going to explain why exactly these image inputs are there later on, but for now let me just connect them. Now once it's connected, you can see that there is some color input which is coming in, and the objects are being textured. Now as you can see, it's kind of dark. The entire output is dark. You can gamma it up so you can see better what's exactly happening. But easier way to get this done is actually to increase the intensity of your direct light. So by default it's at 1. Let me increase it to 10. So this is my three-dimensional lighting which has just happened. Now as you can see, it doesn't really look completely 3D. It's kind of really still just flat. So to make it look a bit more 3D, let me just take a sphere. So I'll just create a sphere in this. I'll connect it into my same scene, and I'll connect it to my checkerboard. Now once it's connected, of course the sphere is too large. I'm just going to tab out of this. I'm going to come out and I'm going to reduce the size. So as you can see, just because there is a light in the scene, you can see that sphere looks three-dimensional. If I disable the light, you can see it's completely flat. Of course, because of the movement, it looks 3D, but it no longer has a three-dimensional shading on it. So that is the benefit of having a light. I'll just go ahead, reduce the radius for this. And after that, I'm going to take this sphere and I'm going to keep it on top of the table. So all I need to do is take this radius, add it on top of the value of the table, so it's exactly sitting on top. I'll move it off to the side. So now I have a sphere, a book, and a tabletop. Now all of these are connected to the checkerboard. We can change the image later on, so I'm not going to edit that. I'm going to go tab out of the 3D view back into 2D, and this is what we have. As you can see, we have the tabletop, we have an object representing the book, and we have the object representing the sphere. The best part about this is that because it's completely 3D within Nuke itself, whatever resolution you have set for your final rendering, that is the resolution that you get your output at, and it's all automatically anti-aliased at that level. So this is the easiest and the best way of getting some outputs. Now I'm going to go ahead and just add in a couple of elements into the scene so that I get more variety. So for that, let me just tab out. I'll pause the video and get back in a second. Okay, so what I've done is I've actually gone ahead, I googled for a couple of images, and I have taken in this one image about of a wood texture which is already lit, and then I also have this one stock image by this person called JQX. He's from DeviantArt. I got this leather pack from him. So I have two images which I'm going to add in to my different cubes to get some details. So let's just get back into the 3D view and see what exactly I'm doing. So first, to begin with, as we already know, this first cube is the tabletop. So I'm going to disconnect it from the checkerboard, and I'm going to connect it to the wood texture that I have. And as you can see, immediately it looks like a wood which is being a wooden table which is being lit. Now apart from this, I'm going to take the other image input for the second cube which I have, which is the book, and connect it to the leather. And as you can see, there is immediately some leather detail which is being added in on top. So as easy as that. But as you can see, it's not really that three-dimensional. The lighting's not set perfectly. So I'm just going to delete the sphere because it was just put in for showing you the benefits of lighting. I'm going to shift into my 3D view, and now I'm going to change the light so that I have a bit more of a shading effect so that I can differentiate between the table and the book easily. So I'm just shifting the light this side so I can see it better, holding control and rotating it so it's a bit more on the side. I'll also take the book. I'll make sure I open its properties so that I can easily rotate it over here. Okay, just rotating the book a little bit. I'm going to move it. The pivot point of the book is changed because the I didn't move the object in the world coordinate system. I actually changed the properties of the cube itself. It's up to you, whichever one you find easier. You can use such methods to manipulate objects, but make sure you do it in the end, you know what exactly you're doing. So as you can see here, I have a wooden table, and on top of which I have this actually a block of leather, but you can just put up a different texture on the sides and such and get a proper output. So this is as easy as that to create this 3D output from Nuke itself. Now the things involved while creating this were, first I created different objects, 3D objects which were involved in a particular scene. I put lights in the scene so that the object gets shading, and then I created a camera for the view which I want to render. So the entire scene is being rendered from this view, and then everything is being put into this camera for rendering. Now if I shift back, I'll just show you what exactly this background node does, this BG node. I'll connect it to my leather pack, and immediately you'll see that the background is shifted to the leather texture. Now one thing you would have observed is that the resolution of the image changed as soon as it's being rendered. That is because anytime you connect a background node to anything at all in Nuke, the background represents the size of the output. So if this background image is really large, then the background is going to be large, whereas if it's small, the background is small. Simple as that. So you can override different settings. So as you can see, the entire output quality is a bit low now because this is the resolution we are at. Now this is a simple scene which we set up. Now let me go ahead and continue along with the presentation. I'll talk a little bit more about creating textures and modifying these objects which you create. So till now you already know how to create different 3D objects, and I've also shown you how to take simple images, apply them before the object so that they are used as textures. The next step is I'll show you how you can apply modifiers or modify different attributes of your object, like moving it or changing the shape. So these modifiers are applied after your 3D object, and once you're satisfied with the modifications you have done, you can connect them into your scene. So now let me shift over to Nuke and I'll show you a few of the main modifiers that you'll be using. So I have just set up this very simple scene here. So as you can see, the scene contains two different objects with a single texture applied to them, a default checkerboard, and a light and a camera in the same scene. So now let me just space out of this. So this is the final render that we have from this scene. I'll just tab out of this to go into the 3D view so you can see what exactly is happening. So I have two different objects, one is a car and one is a cube. Both have been transformed and rotated, so the default values no longer apply. Only the cube, only the plane is sitting at the origin, whereas it's rotated, but the cube has both been rotated and moved. So now once we have applied some transforms, let's say you want to lay the transforms, you want to add in another set of transforms on top of this, or basically move the object. So there is a special node which is going to allow or help you move an object. That node can be found under modify, and that is a transform geo. So if I apply transform geo, you can see that it has very specific inputs. The default one without any naming on it is the input. This is where you input your geometry or objects which you want transformed. Apart from this, we have the axis and the look. I'm going to talk about these in a little while. So let me just disconnect the cube from the scene itself. I'll connect the cube into my transform geo and connect the transform geo into my scene. So now that it is connected, you can see that the transform geo has just given me these handles. This is just like the origin handles or the transform handles that I had for the cube itself. And I can rotate, I can scale, I can do all the operations using this transform geo. Now the reason that this is useful is that Now I can have different values for the cube itself. So for example, I can rotate the cube however I want. I can position the cube as an individual value. I can position it wherever I want, and then apply transform geo, which is like a clean slate. It gives me pure zero values, like I'm transforming the object itself from the origin again. So as you can see, the default cube's origin or the pivot point is in the center, whereas the transform geo is at the origin itself. So this is one way of moving an object. Now let's say you want to move these two objects, the card and the cube, at the same time, whereas you don't want them combined. You don't want these two objects merged. So in such a case, the transform geo can still be used. The way you would use it this time is go into modifier, take a new transform geo, put it to this card, and now we are going to make use of this axis input which you have for this. By default, the first node that I have under 3D is the axis node. So I'm going to take this node. For those of you who don't actually know what the axis node is, it is nothing but a simple placeholder or a locator or a null object. It basically does not get rendered, but it stores, translate, rotate, scale, skew, and pivot values, which you can use to create, layer up your animations or move different objects. So how exactly I'm going to use it is, as you know, the transform geo already has this axis value present on it. So I'm going to take this axis value from both the transform nodes and I'm going to connect it to a single one. So now that it is connected, I'll just come back here. I'll double click on the axis node, so I have the axis node properties are visible here. Now if I move the axis, as you can see, both the plane and the cube move together, like as if they are single objects. So this gives me a lot of control over different objects in a scene. It's like grouping them together. So this way you can move different objects at the same time. Now even though you have connected it like this, you can still go back to the card itself. You can still transform it individually, or you can come back to the axis and transform them as a group. So there are loads of options. You can also apply several axis nodes on top of each other. Like I can take another axis node, connect that to this, and now I can go back to this axis node and move those. So basically I'm like parenting different objects on top of each other. So that's very helpful. It's like layering your transform operations. So that is one thing. So that was our transform geo. I'll get back to what exactly this look operation is in just a few seconds. So as you've already seen, I was taking the plane, and the plane was connected to the axis node, and then I was able to move both the cube and the card using a single axis. But we also have this separate operation known as look in our node. So the look node is basically similar to axis, but instead of actually moving the object, it lets the object stay in the same place, but it makes the object look at the axis node or the node which is connected to look all the time. So what I actually mean by that is, let's say I connect this look node to my axis. As you can see, there is a sudden change. What it does is, because this axis is being connected to the look value, if I move this axis, you can see the plane actually follows through. It actually always tries to look at this axis. So even though the plane stays in the same place, the axis lets it look at or it basically keeps pointing at the axis all the time. So as you can see, the cube which is connected to the axis which is connected to the input here on the transform geo for the cube lets it move, whereas a card geometry actually lets it rotate or always look at the node itself. So this is a very easy way of creating simple rigs within Nuke. I'll actually be using this when I'll show you how to create stereoscopic rigs. It's a much easier way than actually scripting it in. So till then, just try to go through the video again so that you understand what exactly is happening. I will not be using this method for creating the earth composite. I'll be just compositing it by default without any kind of transform geos or anything like that applied. So now, next node which I want to show you is the merge geometry node. So as you can see, the cube node and the card node are being applied into the scene or put into the scene as separate geometries, whereas let's say you wanted to merge them together, have them as single objects. So in such a case, you can use merge geometry to do that. I'll just connect merge inputs to the cube and also the card to the merge geometry input. Now once it's connected, I can disconnect the card and the cube. I'll connect just the merge geo into my scene, and once it's connected, you can see both these objects have come into the scene as a single object, single entity. As you can see, merge geometry does not have a lot of options. So let's say if I wanted to transform this merge geo, I can just directly apply a transform geo to this, and now by moving it, I'm moving both the objects as if they are one. So previously I had to apply transform geo to both of them separately. This time I'm applying only a single transform to move both of them. So there are different ways of doing the same operations. Just make sure you do the whatever you think will work out the best. Now merge geometry is basically something like grouping or combining objects like what you have in Maya, Max, or CorelDRAW. So this is a very simple operations. I'm not going to go too deep into it. Apart from merge geo, you have crosstalk geometry, you have lookup, log geo, and let's just say trilinear. All of these are basically like lookup tables or curves which you have in Photoshop. They take the default values which are already present in the object and try to modify them. So let me just try to open up something like lookup geometry. This is nothing but a simple lookup table. It has 0 to 1 values for all the axes, and by changing these values for different axes, you can change the shape of the objects. It has a lot of power, but it's kind of hard to understand for beginners. So let me just try and show this. So as you can see, the cube which is present on my positive z-axis. So I'll just go to my z-axis here, and I'll tell I want the cube flattened to the origin. So basically I want all the values taken here, and I want them all flattened to 0. So basically I'm taking all the values which are present and I'm taking them down to 0. So basically I scaled down my entire cube and I made it flat. So as easy as that, I was able to get in some values. So there are loads of possibilities that you have while using this. For example, I can actually make it like a comet or a teardrop shape. You can create like raindrops if you have a spear using this. So try to experiment with this, try to see exactly what it does. It's not really in scope for me to go into the details or show you what exactly can be done right now. So all the different ones which I just mentioned, which is the lookup geometry, log geo, and also the crosstalk geometry, does the same operations. So just go through them. Now apart from that, the other thing I want to show you is procedural noise. This node basically adds in specific noise onto any object which you have. So as you can see, I just took the spear, it just took the cube, and it basically added a lot of noise onto it. So it's easy to create some additional values onto objects like this. So I'll be creating an asteroid using the moon texture in a little while for that. Now apart from this, we also have radial distortion. This is a simple node. It's very easy to understand. It's basically like a spherical distortion. You can go ahead, increase the value here so you can see what exactly it does for objects which are at the center. So let me just put this back at the center itself. I can go ahead, take the distortion value and actually increase it to a high level, and immediately you can see what exactly it's doing to the object. Sorry about that. So as you can see, it's adding this kind of a star shape. It's giving you the spherical distortion to the object. So you can use this to play around, add in some extra quirks into your shape. Also it goes into both positive and negative directions. So as you can see, it can create different kinds of interesting shapes for you. So that is a radial distortion. Next, apart from this, the UV project is something which I'll show you in a little while. I'll not use it for now. This is basically used to project your textures onto different objects. We'll actually create a landscape also in this video. So I'll be using UV project to create that. So before that, let me just show you displace geo, which I just missed. So displace geo is a very good node to use. It tries to create some randomness, or basically displaces objects depending on the node which you connect here to the display channel. So let me just go ahead, I'll create a simple, let's say, a color bars node, and I'll connect this to my displace, and as you can see, immediately it gives me some different results. So basically what happened is the color bar's value is going into the node. I'll just connect the image from the cube into the color bar so you can see what's happening. So you can see that all the values which are coming in, especially the CMY values, which are the brightness values, are actually pulling the object out, whereas all the RGB values are pushing the object in. So this way you can add in any kind of geometry details which you want, like a displacement map or a bump map. So if I just go into my cube, as you can see, the resolution is very low, so because of which you are not able to get a lot of details. So I can actually go ahead and increase the resolution here, and because Nuke doesn't really have to create a lot of details, it is quite fast even compared to this. So as you can see, there are lots of details here. Each one is stepped, so it's creating different values. So using this, you can add in a lot of information into your geometry. I'll also be using this for creating some details into my composite. So those were the main modifiers I wanted to show you. So these are the different modifiers which you'll be using most of the times. Now, apart from the modifiers, what I wanted to show you is the shaders. So I'll just get back to you by creating a simple scene here. So you already know how to apply textures to 3D objects and modify them before putting them into your scene. So to apply any kind of shading nodes, they go right before the 3D object itself. So all of the properties or any node involving diffuse, specular, emission properties or complete material, everything goes in right before the 3D object. So now, before we actually start creating 3D shading, let me just give you a brief Photoshop demonstration about what exactly shading means, and then we'll switch over to Nuke. Let's actually understand what exactly shading means within Photoshop itself. So to begin with, first I'm in Photoshop right now. I'm just a simple blank document. What I'm going to start by doing is creating a simple scene where I will show you how exactly or what exactly shading means. And once you understand that, I'm going to go ahead and show it to you how to create the same things in Nuke. So to begin with, first I'm going to start by creating a simple circle. This is going to be my sphere. And with this sphere, I'm going to create a simple mask, so that is the one for my layer. For those of you who don't really know Photoshop, you don't have to worry about this because you'll easily understand what I'm trying to do. It's not about the software. So what I'm going to do is take a simple gradient tool. So as you can see here, I'm going to take a black and white gradient on a radial, and with this mask selected, I can just see what's happening there. Okay, so I'm just going to fill this. So it's filled in the reverse direction, so let me just exchange the colors. So reverse them and fill them. So as you can see, it immediately starts looking 3D. The sphere looks 3D. The reason that the sphere looks 3D is because of the shading. What shading means is the way the light's changing on the surface, the shades of the light or the color that it's providing. So wherever the light is actually falling, which is this bright region over here on the top, this region is completely bright or white, or that is the region where I can actually see the actual color of the object. Whereas where the light does not reach the shaded region, this is the region where we get the shadows, right? Now, the reason the object looks 3D by default is because when a light falls, it creates the shadows on the object. When the shadow is created, our mind is capable of analyzing how exactly the light is falling, and if the light is falling in this direction and if the shadows are there, our mind automatically tells us that okay, the object is actually in 3D. So that is what we are trying to fool our mind into thinking. So all of that we think of, all of that we see as 3D is nothing but the shading or the changing values which we see here. So now if I want to create an object itself, let's say I wanted a red object. I wanted this object to be red completely. So what I would do in such a situation is I'll just go take this simple one here. I'll just make sure I have a black and white gradient here, and now instead of the white color, I'm going to shift it to red. And now by filling in the sphere once more, and just let's go reverse it again. By filling it again with red, you can see it's a red sphere this time. The reason it's a red sphere is because wherever the light is falling, it's giving me the red color. Now, as soon as you look at this, it definitely does not look like as if it's shining. Now, The reason objects shine is because they reflect. When they reflect something, the more they reflect, the more sharper the reflections. If let's say you take a cloth for example, if you see the reflections on a cloth, you can't really see or apply makeup looking at a cloth, can you? So similarly, if you go to a mirror, the reflections are so sharp that the contrast or there is a sudden variation between the dark and the light tones. So that is what makes an object look reflective. So let's add in a reflection on top of this. What I'm going to do is take the same layer, I'm going to duplicate this. I'm going to remove the fill which is present within this layer, just making sure it is blank. Now I'm going to take a default black and white gradient and fill that on top. So let me just go create a small black and white gradient on top. Now because for those of you who are not understanding what I'm going to do next, I'm just applying a simple operation here called screen. So basically what it does is remove all the black and only leave the white values. So now as soon as I do that, you can see that the object starts looking a little bit shiny, right? So I can just place the object a little bit precisely. So you can see that the object starts looking a bit shiny, but it's not exactly that shiny to begin with. So to make it look more shiny, I can actually go ahead and start creating some values, or basically I can start editing it a little bit. So what I'll do is I'll go into adjustments, I'll go into by curves and start editing this. I'll just make it a bit more sharper. So I'll make sure my black is gone and my white is gone, really sharp. So as you can see, there is a sudden change this time from white to red. So that sudden change is what is going to make the object look more glossy, or that is what is going to make the object look more reflective. So as you can see, just in Photoshop, just by taking a simple red sphere, we are able to add in some shadows, we are able to add in some light. So this is all it takes to create some objects, or basically to create something which looks three-dimensional. Just you need the proper shading on top of it. So we are trying to create the same thing within Nuke. So let's get into Nuke. I've created a simple scene. I'll show you what I've done and exactly how to get something similar. As you can see, what I have here is very similar to what I had created in Photoshop, only that there is actual texture in the diffuse itself. Now the network which is there for this image is very simple. So as you can see, there is a simple diffuse shader and then there is a specular shader which is applied to the sphere, and both of them have certain maps applied to them. By just using simple diffuse and specular, you can pretty much create any kind of material you want. So I'll concentrate more on these two materials themselves. So I have a simple scene set up here again. So this scene has only a sphere and light in the entire scene. So let me start by creating a simple checkerboard. I apply that as a texture to the sphere and connect it to my viewer. So as you can see, I have a simple sphere with checkerboard texture applied to it and the light is falling on it. And by default, Nuke already has diffuse shading applied on top of this sphere. Now to start shading this, what I have to do is just on the 3D drop down shader, I just had to check the nodes which I want to get the particular output. Now by default, diffuse is the first thing you would have to pick, because that is going to give you the default lighting, or how exactly the light is supposed to behave on your object itself. So now I've applied diffuse, and as you can see, it doesn't exactly look as good. There is some shading going on, but it looks mostly flat for most of it. So for that, the reason for that is diffuse or any other node which you take from shader already has two nodes or two inputs which are coming into them. One is called the map and another is a default input. When you are connecting this checkerboard, this is supposed to be your map. This is supposed to go into your diffuse properties map. So therefore it's actually connected to the wrong map here. So what I'm going to do is just disconnect it from the default view and put it into the map, and as you can see, immediately I have a different looking output. It looks similar to what I had before when the diffuse was not at all connected. So this is one output which I'm getting now. Now I have the diffuse which is coming in, but as you can see, it's really dark. It's really not that bright. The reason for this is, as you can see in the diffuse properties here on the side, let me just open it individually. So as you can see, the white point is set to 0.18, because of which the brightest region will be darkened down to this level. You can take it down if you want it darker, or you can take it up if you want it brighter. Because I want 1 to be perfectly 1 in the final output, I'm going to just go put it into value of 1, so that I know whatever color I put in will be the exact color which comes out. So now that I have this output created, what I'm going to do next is apply some specular highlight on top of this. Now I'll just take my diffuse, take it up. Just to organize things a bit better, I'll just put the map on the side. Next node I want to apply is the specular. I'll just take in the specular. As you can see, specular also has certain maps which can be connected to it. So it has a map sh, and then a simple map, and then it has the same default input. Now when we are going to connect the specular into this node pipe, we should make sure that it's the unnamed input, the default input, which is being connected from diffuse, because we want specular to shade whatever output is coming in from the diffuse and not actually use diffuse itself as a map. So therefore I'll just put in the specular, and as you can see, this is the default way it got connected. And if you observe, it also has a specular highlight. I can just go ahead, increase the highlight brightness, and you can see that the highlight increases. I'll just keep it to 1, so that is just a default value, but you have to remember that whatever specular you're applying is being screened on top of the diffuse itself. So now if I go to the highlight itself and place my mouse on top, you can see that the value here for the white point is much greater. It's more than 1. You can also see it's out of gamut. So I can take this down if I want, so that it's not actually out of gamut, but it doesn't really matter for this, because it definitely most of the time specular highlights or reflections are out of gamut when the light is falling on them, so it's better to have them as such. So now I have a simple sphere. I have some kind of specular highlight also applied on top. So now this is a very simple material I have created. Now let's just say that instead of this checkerboard having this the spear being this checkerboard texture, I want it to be that same red color. I can just go back to my checkerboard, start changing the colors here, and as you can see, immediately the changes are almost real time, not exactly real time, but almost real time, and you can still see the effect is being carried across. Next, the next step is the specular highlight itself, which is going to give you most of the properties of the material. Like you can see, if I just go ahead, disable the specular, you can see the object looks like it's matte, or like it's not reflective. It looks like it's made of rubber or maybe paper or something which is not reflective. Whereas when I turn on the specular, it starts looking shinier. So therefore whatever material you're trying to get, you're supposed to get a proper specular highlight on that to get the best output. So the 3 properties you want to change include the white and both the minimum and maximum shine. By default, the minimum and maximum shine work together. So therefore, if I go ahead, change the minimum shine to, let's say, 0, you can see that it did change, but it's not a lot. Whereas I can take the maximum shine and, let's say, go up to 100, and you can see the highlight becomes sharper. So as I was telling in Photoshop, the simple demo that I gave, the sharper the highlights, the more reflective or more glossy the surface looks. So you can actually take this to a greater number, and therefore you'll have a much sharper highlight. But as you can see, the highlight is too small and it's not visible. So now I can actually take the white point and increase it, so I can actually see the highlight itself. So there's a very glossy spear, but because the highlight is too small, you can't actually see it this time. So therefore try to have a balance between the highlight, white point, and actually the minimum and maximum shininess, so I can actually see the highlight itself. Now we have this. Next step is to actually go ahead and shade the object so that the highlight is being used properly. So as you can see here, the surface wherever it has a lighter color has more of the specular highlight, whereas the surface which is darker in color is eating into the specular highlight itself. So this is something which you can actually map in. So what I'm going to do is take in a simple noise. I'll take a constant, I'll apply noise to this constant. So it's a simple noise. I'll just look through it. So you can see this is a very simple noise which I'm getting, and I want the spear to have specular highlight being modified as such. So I'll just come back and look at the final output which I have here. Okay, so what I'll do is take my specular map shading. I'll just connect it to my noise, and immediately you cannot really observe any difference there. The reason for that being the map SH property is actually taking in the minimum shine and the maximum shine values and merging those together while creating this. To show you the effect, I'll just take the white point for the specular shading back to 1 and take the minimum shine, let's say, down to 50, so that the minimum shine is larger. So let's just make it a bit more larger, let's say 0 itself. So as you can see, the specular highlight now starts to show some noise, right? So there is some kind of a variation in the specular noise itself. So this is the kind of effect you would usually want to have, of course not so harsh. The reason for that being, no natural object is perfectly shiny. There is always some kind of variation within it. So this mapping kind of tries to exploit that. So by just creating a simple noise map, I was able to make use of it. So now this is the noise map which I actually have, and I actually can go ahead and start editing this. I can make the frequency lesser, and now if I shift over to my final view, you can see the specular also started changing. I can go ahead, okay, this is too high. Okay, so as you can see, the specular highlight also has the same kind of texture applied. So I'm being able to actually manipulate the specular highlight individually. Also, instead of just connecting it to map SH, I can also connect it to map itself, specular highlight, and as you can see, it's affecting the overall specular, not just the minimum and maximum shine this time. So if you want to affect the overall property of a shading node, connect it to map. If you have a map SH or any other node, it probably involves manipulating one of the other properties. So now I have a simple property being manipulated. I can actually go ahead, connect it back to SH. So I have this back again, and also this is pretty much the entire sphere which I wanted to show you how to create. Now apart from this, as you can see, this region, the region which is completely dark, is perfectly pitch black. As you can see, it has absolutely no values other than alpha. So therefore, if I need to have some values or certain values even in this region, the way I can start getting that is by applying an emission node. So in shader, we have something called emission. So this emission is basically something like self-illumination. So using this, I can make sure the object is not completely dark. It has some values. So I'll just connect the emission after my specular. And as you can see, the object immediately starts looking like it's translucent. That is because the emission property is making sure the object has a minimum of this value, or minimum value of 0.18. So therefore, all the blacks are being taken up to this value. Let's just say I don't want it to be so dark or light, whatever it is. I can take it, I can put in, let's say, 0.1, and immediately that value is considered. Of course, I can also connect it to any map I have, so that the emission is actually taking that into consideration. So as you can see, the emission property is affecting both the region which has shading on it, and also the region which has a shadow on it. We'll be making use of the emission map in the earth composite so that we can get some city lights in the background. So now you already have seen how to take these different nodes and connect them together. Now let's actually see how to create some complex materials. So we have one system, or one set of material which I have created, where actually a checkerboard is a diffuse texture, and we have some noise in the specular highlight and also in the emission properties. Now I'm going to go ahead and create a new shading network. So this time I'm taking a simple diffuse, and I'll apply, let's just say, I'll just take in the noise from here. I'll just start adding, let's just say, simple specular on top of this. So as you can see, I have a diffuse created with the map from here, the noise map, and then I have a specular map created from here. I'll just keep this in the center so it's easier to understand where all it's being used. Okay, so as you can see, it's a very useful way to create different materials out of the same maps. So now that I have a material created, I want it applied, but I want it to be applied to the same sphere. But as you can see, if I take the specular output and I connect it to my sphere, immediately it gets disconnected from the emission properties and it's connected only to the specular itself. But I want it to be connected to both the emission and the specular. So to merge them together, what I actually have is, if I go under the shader, I have a merge material, which is exactly the same as merging your different layers. So if I take this, you can see it has a and B channel, and I can connect one to A and another to B and give the output to my sphere. So as you can see, I'm actually taking in two different outputs and combining them together. So I can actually go ahead, change the operation which I want, let's say plus. So both the materials are being added on top of each other. So as you can see, it giving a lot of these specs on top. Instead, I can even go use anything like replace, where one material is replacing another. So as such, you can actually go ahead, merge different materials together and create new materials of your own. So this is a very useful node to have, and I will be making use of this while creating the earth composite. So for now, the main things that you have learned till now is includes how exactly you can apply textures to your nodes, so that you can create something simple like this. So I'd created a simple tabletop and a leather texture on sitting on top of it, and then I'd shown you how exactly you can apply some create two or more objects, apply transforms together, create some modifiers on top of them, etc. And then I've shown you what kind of output can be created just by applying some shaders. So now you pretty much know most of the things involved in creating 3D composites. So now let me go ahead and create a few more composites so that you get a complete grip on the concept of 3D compositing within Nuke. So to get started with, there are several things I want to do. So most of the thing that I'm going to show you include the things which I've already shown, but in different contexts, so that you understand things in a more intuitive manner. So let's just get started by creating simple composites. So in the previous section, I've already shown you how to create the simple composite. For this, we had two different cubes with specific images coming into each one of them, a single light and a camera in the scene, and then we had this output. But of course, this output doesn't really look that good. The same texture on the top of this slab is applied to all the sides, and therefore you can see that the side is really not that good. And also the tabletop itself is kind of flat shaded. The lighting which you are seeing is actually there in the image itself. And also one thing you'll note is that there is no shadow of the book cast on the table itself. It looks like as if the book is floating on top. So what we are going to try and create is this, where you can see that there is loads of texture on the object itself. There is certain textures on the sides, and also as you can see at the bottom, let me just refresh once. So as you can see on the sides, there are these textures applied, so it looks like there's some pages coming in across it. Also there are shadows and also some ambient occlusion which is being faked. And the lighting is being removed from the side, so it looks like it's actually some planks which are coming inside. So the network we have for this includes something like this. So as you can see, this is for the tabletop itself. So this was the one we had previously, and what we have now includes this. So as you can see, this is the tabletop we had. There's the entire network related to that, and then we have this network which is related to the book itself. So there are loads of things happening here. So before we get started by creating this composite, let me show you how to create projections within Nuke, and then go about and show you how exactly you can create this entire output. So within Nuke, there are two ways that you can actually work with projection. The first is manipulating the texture which is being applied on the object, or in another way, you can actually manipulate the UVs itself on the object. The first method, which is applying the texture using projections, is what I'm showing you right now. So to do this, we can go under shader, and here we have project 3D node, and this node is going to help us create projections using simple textures onto objects. So the first projection texture, I'm just applying it just before the image is connected to the card itself. So as you can see, there is a sudden change which just occurred. Now what this projection does is it gives you a camera input. So wherever this camera is present, or wherever I connect the camera from, that is where the image gets projected from. So I'll just create a simple cam. Let's just say I connected to this. So as you can see, immediately the whole output went blank. The reason for that being, in my 3D view, as you can see, the camera is sitting exactly at the origin. So what I'll do is take the camera and move it to the back. So immediately you'll start observing that the camera itself is creating the projection. One thing to note here, the object which I'm using is not exactly the same resolution as my project settings, which is 2K 35mm. So for that reason, I can apply a reformat node onto this, and immediately I'll set it to fill. So you can see that the object is filling exactly the corner points of my camera, where the camera points are intersecting with the plane. So now if I want to, let's say, have the object projected from some other angle, all I need to do is take the camera, move it wherever I want, and the texture follows. Not only this, even when the camera is rotated, you can see that there is perspective distortion being added on the texture. And the best part about it, when you're rendering out your final scene, you're no longer using the same camera which you use for texturing, which is over here. You're using a separate short cam, because of which the texture appears distorted, or you could distort the texture beforehand so that it appears undistorted here. So this is a very simple way of applying projections. So here what we have done is taken a texture, forget the reformat here, this is entire thing is just the texture. We are using this camera to project the texture onto this object. Very simple process. So next step, I'll show you how exactly you can apply multiple textures and merge them together using the same method. So let's just say that you already have this texture applied, but what you actually wanted is this wood texture being applied to the entire plane itself. So therefore it has to be like this. But let's say you wanted to add in some other detail on top of this texture itself, which is a projection. Like for example, the shadow of the book, which I wanted to add it on top. So for such things, what we can do is actually merge materials once we project them. So let me just go ahead, disconnect these nodes, and I'll re-enable this. Let me take a checkerboard and connect that in as my default texture. So this is the actual texture which is being projected onto the plane this time. But what I want is wherever I don't have the checkerboard texture, I wanted to have the actual plain plank texture itself. So for this purpose, what I can do is go ahead, I can take under the shader, I have merge material, and this merge material gives us some very basic mathematical operations like subtraction, addition, or basically you can use it as max min. You'll have to plan this out beforehand about how to use it. Let's say you are going to use shadows. In such a case, you can use it to minimum so that shadows are being added. It acts kind of like multiply, not exactly. So you'll have to test it out. Now what I'm going to do is connect it to both of these textures and just exchange them so that this wood is my actual background node which is coming in, and then I'll set it to minimum, or let's just say plus, so that I can see both of them at the same time, and connect the texture from the card to the merged material. So as you can see, immediately I have my original node or my original texture for the plane itself, and then I have this projected texture which is being shown. So if I come into the 3D scene, I can take the 3D cam, I can actually move it around, and you'll see that the 3D texture, actually the projected texture actually starts being updated. So I can easily add in different textures layered on top of each other, projected from different angles, and merge them together. So if you have, like, let's say 2 different textures which you're adding in together, and whichever area which is an overlap, you can just set it to black and then set it to plus or maximum, so that you get specific outputs. You have different operations which you can use over here. So as you can see, by using the same method, I've just used merge material so that I have a simple texture which is being applied to the UV coordinates, and another texture which is actually being projected and then being applied to the card itself. The last method which I'm showing you right now is going to affect the UV coordinates of the objects. So all the textures which are applied to the objects which make use of the UVs will be affected. So for example, here if you observe, this texture which is applied to the object is not projected, or there is no UV mapping or anything as such, or any UV manipulation happening for this. So this texture will be affected, whereas this project 3D node, which is already applying some coordinates onto this texture, will not be affected. So this is only going to affect those textures which don't have any kind of projection applied to them. So with the project 2D node applied, let me create a new camera for this. I'll connect it to my axis, and now as you can see, immediately the checkerboard is still there, but whereas the background map which you had for the object itself is gone. So now I can take the camera, I can move it, and you will see that the wooden texture is being manipulated. It's only in the viewport that you can observe that the checker map is gone. That is only a viewport display thing, whereas you can move the object around here and you'll see that it's only the texture which is making use of the UV coordinates which is being manipulated over here. So you can actually go ahead, animate the camera, you can do loads of things to get the final output that you're looking for. So this is the last method which I wanted to show you. The next thing which I'm going to show you is how exactly I created this entire network and how I created this output. So finally, to show you what I have done to create this output, let me just play the video once. So as you can see, there's a three-dimensional scene with a box at the bottom and a box at the top. The one at the bottom is textured as it's a wooden plank, and the one at the top is textured so it looks kind of like a book, and the tabletop is also textured so that it looks like it has some kind of a shadow going on. So now I'll show you how exactly this output was created. To begin with, first let's take a look at the wooden texture itself which I have here. So as you can see, this is the default one which I had, but then I took the same texture and I merged this additional texture on top of it. So this is nothing but a simple rotor paint which I've applied onto the texture itself. So I took a simple constant and I applied a little bit of noise. The noise is not really visible here, and once I applied the noise, I then went up to the rotor paint. I drew up a simple shape. So you can see this is a very simple shape which I've drawn, one which is giving me the very solid black color outline close to the object itself, and then a very hazy outline which is going outwards. So this is going to give me that soft shadows which I had. So now once this was created, I went ahead and merged it together to create this output. So this is basically the wooden texture with this multiplied on top. So basically I'm adding shadows. So once this is done, I had to connect them to the cube itself. So this is what I created. So this is what I had. But the problem with this method is if I go to the sides, you can see that the same texture is even applied to the sides also. So let me just go here. I'll turn down the divisions. Okay, so as you can see here, the same texture which is there on the top is also being applied onto the sides. And it doesn't really look good to have this shadow being applied on all the sides of the table at the same time, because it's basically using the UV coordinates, and all the UV coordinates for this box are like overlapping with each other. So I didn't want this to happen. So for this reason, I had to project this texture from the top so that it's being applied only from the top and not onto the sides. So for that reason, I took this cube and then I took a UV project node and projected using this camera. So this camera is present here at the top. You can see this camera is present at the top. It's touching exactly the sides of the board. So I just moved it so that it's touching exactly the sides. And because the camera is projecting exactly on top of the board, you can see that once I shift over to the UV project, the texturing is changed, and now the texture which is being projected is used and no longer the one which is being applied. So this is a UV project node which is actually manipulating the UVs of the object. So I can see this. All the black nodes which I have here, I'll talk about why exactly they're black in a second. Let me talk a little bit more about the book itself. So if you see the book texture, you can see it's actually in 3D. The book texture. The reason that it's in 3D is because the camera which I'm using, which is here onto the side, is actually looking at the object from a three-dimensional point of view. So let me shift over to the camera. So you can see this is the camera which I'm looking through at the book. So what I did is, because I'm using this camera for projection, I took a screenshot of this itself, or basically I took the cube, I scanline rendered it, and I wrote out the UV snapshot of this output. And then here within Photoshop, I just took the simple snapshot which I took by applying a checkerboard onto the object, and I created this additional texture on top of it. So once this is done, I went back into Nuke and use the same camera for projection, the one which I used to take the snapshot. I use the same camera to project this texture onto the cube, so that now when the camera is looking through the object, it's seeing exactly the same. Now if I just move the camera to the side, you see the texture itself is sliding and it does not fit the object. So this texture is only valid as long as the camera which is being used is looking straight at the object from the same angle as the texture. So by using this method, I was able to texture the book. But there is a problem with using this method of texturing. This is usually used for creating landscapes and such. The problem is that the region which is not seen, the region behind the object, has the entire texture smeared all over it. So you can see the same text is being smeared onto the sides and everything. So when you're trying to use projections like this, make sure that the camera which is projecting onto the object is going to cover the maximum area which is being seen by the render cam. So now once the cube is being created or being set up, I went ahead, connected it into my scene and rendered it out. The only other thing I've done in this scene compared to the previous one is added a spotlight, so that when I look through here, you can see that there is some more detail onto the side of the book, which is now visible, which was no longer present when the light was not there. So this is how the object looked like in the shadows beforehand when the spotlight was not there, and now after adding the spotlight I have more details. So it's always about making sure your objects have enough detail. So now if I want, I can also come into the spotlight and I can change the hue and get in the exact output which I'm looking for. So let me decrease the blue and the green, so the output has a bit more reddish tint into it and it adds in more look. So this is how I created this output. Now let's take a look at what exactly these black nodes are. Let me start by unhiding all of my nodes. So to begin with, all the black nodes are what I like to refer to as helper nodes. So these are the nodes which are actually helping me to create the composite, but they might not actually be necessary to create the final output anyway. So this is not supposed to be black, so let me just change the color a little bit so it's slightly different and easier to see. Okay, so all the black ones are the ones which can be removed or deleted without any without bothering the composite on itself. So first, let's understand why exactly I've created these nodes here at the bottom. To understand them, let's see why exactly we need them. To begin with, first I told you I created this shadow so that the book so it looks like the book is actually casting some shadows onto the table itself. But to create this, you can see that if I come back to the final output and open up my rotor paint, you can see the shape of the final output and the one which I have used do not match. The reason they don't match is because whatever I have taken is being projected onto the object, whereas the final output is being looked through a different camera angle. So for this purpose, what I needed was a different view which basically tells me what I need to draw to get the right output, or basically what I need to draw to get this output. So to create it, what I first started doing is I created this merge geo node, where basically I took two different objects, both the table and the book, and I combined them together in a single output. So once I combined them, I connected them to the scanline rendering. So this scanline rendering is making use of the projection cam which I have here to give me this output. So this is actually what is being looked at, or this is what the camera is actually seeing. So once I have what the camera is seeing, I wrote it out and read the image back in. So when I have this image, I just had to open my rotor paint node, and as you can see, all I need to do is draw out the shape of the shadow which I wanted. So once I drew out the shape which I wanted, immediately that texture was created. So that's all is required. All I needed was a reference image, and for that I created these additional nodes to just get that reference. In the same way, here at the bottom, as you can see, I needed the projection which I need to put into the book itself. So this projection, so for that I created a scanline renderer, and with the help of the scanline renderer, let me take a checkerboard here to just quickly display this. So with the help of the scanline renderer, what I did is take the camera, take the same camera as I'm using for the projection. Okay, this is the one, and take the screenshot of this, write it out, and use this in my Photoshop to create my final texture. So that's how I got the book texture. So as you can see, the black nodes are the ones which are actually helping me to create the composite. They're not actually necessary. I can delete them once my final composite is done. So this is how I created the projection texturing. Okay, so finally this is the result that we are trying to obtain. So as you can see, we have a flyby of Earth there is a 3D moon, and there is a 3D earth, and there is a huge star field in the background. So to start creating this, I'm going to show you what exactly is the process involved while creating something like this, rather than go and create the entire composite in the video itself. So I've already gone ahead and I've created the final composite. So as you can see, this is the final composite, the entire thing. This is going to give you the result that we are looking for. And here on the side, this is the scene that we have for this output. So as you can see, we have this outer sphere, which is our star field. So it has a texture mapped onto it. And then we have a camera which is moving through the shot. So as you can see, there's a camera there. And also we have an earth at the center of our scene. It has been textured and has been put in the center there. And apart from the earth, we also have the moon. So with these objects, all you had to do is animate the camera, add in some lights too, of course. So animate the camera, and once that is done, we have this going on. So to get started with this composite, let's first go ahead and collect a few textures. So the first texture I want is the earth and the moon. So these textures can be obtained from this pixelplanetemporium.com. This website has a load of images related to all the planets of our solar system. So you can go ahead and download the textures which are required. I have just downloaded them, and I have not actually changed any names, so you know exactly which texture goes where. So I've actually been using the earth map, the bump map, specular, city lights, cloud map, cloud transparency, and the moon 1K resolution map. There's also a bump map which is here, but I'm not actually used the bump map from here. So let's actually go ahead and see how to get started. So here inside Nuke, this composite, I have just gone ahead and created loads of backdrops and labels, which you can see here. Each label tells what exactly is happening in that particular step, so it's easier for you to understand what's happening in the composite when you go through the file. And also in this composite, as you can see, there are loads of things happening, but one thing is this last section which exists, the secondary glow on earth. This section I'm going to skip in the tutorial, but it's I've made sure I've put in detailed notes about what exactly is going on, so you can actually understand what's happening. So what I'll be showing you right now is this section over here, and I'll show you what exactly I have done entirely to create the final output. So let's get started here. So to begin with, first I have the earth map itself. So as you can see, this is the earth map I gotten from pixelplanetemporium.com, and this earth map, if you observe, is not really that high res. You can get the high res from the website itself. You just have to pay a little bit for that, whereas for this tutorial I didn't want to. So I have this very pixelated image, and it's quite good. It has a lot of details which I can use. So I wanted to use this texture and go ahead and first add in some extra details. Like for example, I have enough pixels here to actually add in some additional information about the rivers, and like just increase the amount of detail which already exists. So to do that, what I did is I went ahead and took the elevation map or the bump map. So as you can see, this is nothing but the elevation of the entire surface. So as you can see, the region near the Mount Everest is really high, whereas the ocean and all, okay, the ocean is of course dark, it doesn't have any mapping on it, but as you can see, all the mountain ranges are really high, the rivers and oceans are completely low, they're black. So this is a map which I'm going to use to create some additional details. I'm not going to use it as displacement or for shading. I'm just going to fake everything into it. So the first step of doing this is I have my earth map and I have my earth bump. This earth bump, as you can see, has only a single channel in it. So if I go ahead, shift the channel to RGB red and shift it over to alpha, you'll see that it's completely just black and white. There is some problem with the image because of which it only loads this part of it. So anyway, As you can see, the image is just a grayscale image of the Earth's bump. So what I've first done is taken this elevation map and I've actually added it into the alpha channel of the color map which I'm getting in from here. So all I've done is taken the RGBA values from this Earth bump and shifted it to the alpha value, whereas I'm using the default RGB. So RGBA alpha, RGB is coming in from here and the alpha is coming in from the Earth bump. So basically the channels have been shifted. As you can see, I've added in a label which exactly explains what I've done there. So once that is done, I've added in this emboss alpha. So this is a default node. What it basically does is gives you an elevation map, like a bump map. So there are only few controls here. So what I'm using is a traditional simple method of creating this bump map. As you can see, it created some elevated areas and some lowered areas. So once I have this, all I wanted to do was add it on top of my final image. So basically I'm trying to fake my bump mapping. So before I did that, I just went ahead and sharpened it. So as you can see, there is this very slight difference. So as you can see, there is a very slight difference in the pixels. They just get sharpened up a little bit. So I just added it in to get more of those. So once it's sharpened, I went ahead and merged it with hard light on. So what basically hard light blend mode does is that it takes the darkest values and it takes the lightest values and adds those on top, whereas it ignores anything which is 50% gray. So basically, if I come back to my emboss map, you can see this region which is here, this region in the center, it's almost close to 50% gray, so it gets ignored, whereas all the details which are going downwards, like the shadows, get added, and all the details which are elevated get added. So therefore hard light is the best one to use to get this detail. So if you see the difference, so this is the original. As you can see, it looks kind of faded out, and this one adds in a lot of details. It gives you much better quality for just adding the simple nodes. So once I have that, as you can already know, I took this bump map and have added it into the alpha channel, whereas I don't really want it in the alpha channel throughout because it might give me problems later on in the composite. So I went ahead and I added remove alpha and I removed the alpha channel alone. So therefore this last output which I have here does not have an alpha channel. It's just a simple RGB output. So if I go to the alpha, you can see it's completely blank. So this is the final Earth image I have. Just simple processes just to increase the quality a little bit and add in some details like bump mapping. So once this is done, I went ahead and started working on the clouds. So as you can see, we have color map for the clouds, and then we have a cloud transparency map which they have provided. But one thing I noted, that Nuke's alpha value, or the way the transparent map is being provided, it's inverted. So because of which I went ahead and inverted it so that Nuke is able to understand how to use the alpha properly. So once that is done, I went ahead and shuffle copied it just the way I did before. So this is the RGB channels and this is the alpha channel. So I went ahead and applied the alpha channel itself. So now if I come to the alpha channel, you can see this is the alpha channel, and then I have the RGB channels here. Also another thing I have done here in the shuffle node is that I went ahead and removed the green and blue values which I had, and I am only using the red values of the entire image. So because of which the blue is automatically removed and my entire image is desaturated. So this is a method I usually try and use so that my entire image maintains the maximum brightness and it gives me the best results possible. So once I had this, I went ahead and pre-multiplied the image, so I get rid of the halfway alpha regions. So as you can see, there's the difference. All the regions which have halfway alphas get pre-multiplied and it gives me the best looking output. So once I had this, I went ahead and created the same emboss effect which I had over here. So I went ahead, applied emboss on top of this. So this is the kind of effect I got from it. So as you can see, it looks like the clouds are actually there floating on top. So once I had that, I went ahead and merged it on top. So by doing this, what I have is this result. So if I come here to the top, you can see the clouds look a bit more detailed. So this is what I was looking for. So once I had the cloud, so as you can see, I already have the alpha for this too. So once I have the cloud, all I needed to do was go ahead and merge these two together. So when I merge them, I have the earth itself with the cloud on top. So another thing I could have done here is actually merge the emboss after the screening operation here, so that the cloud actually casts shadows onto the earth. That could also work. So of course it's all up to you. So once this is done, as you can see, if I come back to my alpha channel, I will actually have my clouds alpha, whereas I really don't want any alpha in the output at all. So for that reason I went ahead and removed the alpha channel here with using this node, and once it's done, I went ahead and applied this entire image, the final output which I have, into my diffuse. So now if I go look at the diffuse itself, I really can't see anything right now because I need the sphere loaded in. So this is the earth sphere which I have. Oops. So this is the earth which I have, and as you can see, this earth automatically has the entire map applied. The quality is very low, so let me just go ahead and increase the resolution of this. It's better not to have a high resolution like this. It's better to work with low resolutions because your system would not hang or give you a lot of errors. So as you can see, there's a lot of detail, but there is one error, a problem with this mapping which you have, which is with the clouds. As you can see, it does not repeat. It gives you the seam across the entire map, and it doesn't really look very good. So I tried to kind of work around this so that this region is not seen when you see the final output. So I'm just trying to hide this entire region itself. So that was how I created the diffuse. Now next thing is I wanted to create the specular. So this is the specular map which was provided. So what it basically tells is that where you have the water or wherever you have the ocean, this is the region which is going to reflect the sun, because land doesn't really reflect as much as water. So when you look at earth from outer space, it is the water which is reflecting. So what I want is this region, the red region in this image, to be the reflective one. So once I have this image, all I had to do was go ahead and edit a few details. So I've added a reformat node here. I'll just come back to it in a second. Let's go into the shuffle node. So as you can see, what I've done here is just went ahead, done the same thing I had done before, taken the R channel or the red channel and applied it to all the red, green and blue channels. So I basically have a black and white map of the entire specular channel. So it basically looks like an alpha map and I can easily see what's going on. So once I had this, I went ahead and graded it. So it's basically 1/4 the brightness. So you can see it's 1.5 here at the bottom. So it's 1/4 the brightness. The reason I did this is because the Earth's ocean is not like a flat ball, or it's not a flat surface. It has waves in it. It has storms raging on it. So because of which there is some variation. There will be like specks on top of the ocean itself. So to get this kind of detail, I went ahead and applied some noise. So as you can see, even the land right now has certain amount of noise applied, so even this is going to give me some amount of speculum. So of course a region like the Sahara Desert or like the Himalayas, they're not going to actually give you a lot of like specular highlights, whereas the snow-capped region of the Antarctic and the Icelands, that's going to give you a lot of speculum. But right now really you can just go ahead and roto those in, but I really don't want to go ahead and do all that. Next, apart from this, I went ahead and applied another noise map which gives me this loads of specular dots. So as you can see, it's a small amount of dots which has just been added in on top. So now the reason that this reformat here is applied on the top is so that these dots which are applied are as small as possible. So if I disable this, you can see these dots are really large, and that will be, give us like it'll be easily seen and it'll look fake because you can see the pixels. So because I was adding this noise here at the bottom, I just wanted it to be a higher quality, so I just added in this reformat so that this noise is really small and you can't really see the pixels in the later on. So this basically in the end gives me the final specular map which I wanted. So let's actually see the result of only the diffuse and specular individually. So let me go to this output here which I have. So as you can see, we have the earth here. I'll go to a frame where the earth is close enough. Okay, so what I'm going to do is just start disabling a couple of these nodes. So I'll disable the moon, the star field, so that the star field in the background is not rendered. And let's go ahead, disable this emission, and disable the specular. Okay, so from the top, if I disable the clouds, you can see this is the simple default earth that we get. Now with the clouds added on top, this is the result that we are getting. But of course the clouds cast shadow on top of earth, so you can go ahead and actually multiply that on top, but I really don't want to do that. So once the clouds are added in, next came the specular highlights. So just to see the specular highlights in action, I'm going to disable the clouds layer and enable the specular. So as you can see, the specular has come in, and you can see there are loads of these specks on top of earth, and it basically makes it look much better. The reason for that is every time you're trying to create a composite, try to have details which are a few pixel levels to somewhere half range of the entire screen to the entire range. So basically something which is very small like this, something which is a little bit bigger, and then as big as possible. So 3 levels of detail so that it looks much realistic. So let me just add in the clouds. So one problem here, if you have noted it, is that the specular highlight is being actually added on top of clouds, whereas clouds are not supposed to get any specular. They're supposed to be underneath. So you can actually go ahead, take the cloud map, merge them with the specular itself, so that this cloud is cutting through the specular. So it's all up to how much details you want. Now apart from this, if you know that earth in the nighttime will actually have all the details, like for example city lights and such things. So basically we also have a map here which gives us the same thing. So this is the city lights map. So as you can see, this is the map of earth in the night time. So this is basically telling us where exactly cities are and how the lights are lit up and what can be seen from outer space. So this is exactly how earth looks like when it's in the night side. So to get this output, all I had to do was, once my specular is combined, I only had to apply the emission properties. So if I come back to my final, you'll see that here down here on South Africa, you can see that the specular is actually working, this emission. You can see these city lights are adding in some kind of detail. So basically the entire night side of earth is not actually completely dark, so it gives you these city lights. And of course if you see, the city lights are actually adding some details everywhere else too. You can go ahead, create a matte if you want, so that the light side does not actually get any mapping, whereas it's not really necessary for this tutorial. So once I applied this, next step was to actually create the moon. So for moon, of course I got the texture again from Pixel Planet Emporium, and this is the texture. It's a grayscale image of moon itself, and it's a spherical mapping which has to be applied on. Now first thing I did again is to use shuffle, so that all the channels from red get distributed, and therefore I basically get something like this. So it's a black and white map of moon itself. So once I had this, I went ahead and graded it. So I just brightened it up because it was too dark, and moon, because it's covered with a lot of dust, is kind of amorphic. So basically it doesn't give you a lot of specular highlights or anything as such. So it's basically like a Lambertian ball. So it just gives you a Lambert shader. So therefore I just applied a diffuse on top and then had the final moon. So let's go ahead and see the final output of moon here. I'll go back to the front frames. So this is the moon which you can see. So as you can see, it looks quite realistic. The light is falling. You can see that the shadows are aligned from the image itself, so I don't need to align them. And of course there is the dark side of the moon itself, and as you can see, there is some lighting here, even the dark side, whereas earth had an emission map. Earth had this emission map of the cities, whereas the moon doesn't have any emission map, but still you can see the dark side. The reason for that is because I've added in this fill lighting into the scene. So there is not just the sunlight, but there is also a fill light. So it is because of this fill light that you can actually see the dark side of moon, whereas it's not supposed to be so bright, whereas I just added it in for the effect. Now I have the earth and the moon created, and as you can see, it's really fast. The rendering is really fast. You can see it's almost real time. Of course it depends on your system configuration. Now once I had this, all I had to do was fill in the background. As you already know, the scanline renderer already has this BG node to it, so I can go ahead and take the BG node and apply it to the star field which I have. So I can take it and apply it to the star field, and immediately I get to see this result. But of course, if I have this, when the camera is moving, you'll see the background is static and it doesn't really look very realistic, because with a static background it doesn't actually look like the camera is moving, it look like Earth itself is moving. So for that reason, I actually wanted the background or the star field within the composite itself, and for that reason I had to apply a star field sphere. So what this is basically this large sphere which I've taken in, so it's almost covering the entire scene. And once I had this sphere covering the entire scene, all I had to do was go ahead and map the texture file onto it. So if I come in here, so with this star field, all I had to do was go ahead and apply the texture onto the back of it, so that when you look through the camera itself, you'll see that the star field exists. So it's just a buffering problem, because of which you can't see the background. So as you can see, this image is applied. Now one more thing that I've done with the star field here is, if I just zoom out of it, if you see here, the image is not actually covering the entire section, it's only covering a small portion of the sphere. This is the entire sphere. You can see only a small portion of it is covered, and the way I did that was I just went ahead into the star field, and here and over here you have the U and V extent, and by default it is set to 360 180, because of which it wraps around the entire sphere, as you can see here. Whereas I went ahead and decreased it to a value where basically the viewing angle of our camera. So if you see here, when I just play through the time slider, we have our camera and it's not actually going out of this region at all. So I didn't really want to go ahead and texture the entire region such that my camera is looking at anything else. So when the camera is not looking at anything else, there is no reason to texture that region. So have a maximum resolution map possible only for that region. So I got that done. So once this is completed, all I had to do was make sure my lighting is correct. So for my lighting, I had my sunlight. So as you can see, it's a direct light. I kept it at an angle to my camera so that the earth or the moon, both of them have some kind of shading going on top of them. So this direct light is just kept onto one side, and I have named it sun, so it's easier to remember what it is. And also when the object is not actually selected, you can see there is the sun name, like you can see it over here in the viewport itself. It's called sun. So now the first thing is I made sure the color from the sun itself is not completely red or white. I actually gave it a little bit of an yellowish tint over here. It's harder to see, but it's a kind of yellowish orangish tint which is given it to the sun. Now apart from that, I made sure it's rotated and looking in the right direction. The next thing is I went ahead and increased the intensity from 1 to 1.2, so it's actually a bit brighter than it's supposed to be. Next, I went ahead and created a fill light which is on the opposite side. So it's not exactly perfectly opposite to the sun itself, it's just like overlapping the sun too, so that this light has a very low intensity. It's a 0.015. The reason for that is because the night side of Earth really does not get a lot of light. The only light it gets is from the moon, the majority of the light, and the rest of the light is from the stars, and it's not much to actually illuminate it compared to the sun. So this is just there for adding in a bit of detail in the darker regions. So what I have done here is basically created the Earth's color and bump. I basically added in all the details, added the clouds together over here, and then added in the specular maps. Once it's done, I had my final Earth, and once my Earth is completed, I went ahead, created moon. As you can see, moon was a very simple thing here. Then I created my stars and put them all into the same scene. So in the scene I have a sun and a light. Now the next step of the process was to actually create the camera animation. So as you can see here, the camera has this animation where it goes from behind the moon and it actually travels through, passing through them. So to create this animation, the way I did it is, first I took this axis node, as you can see. So this is the axis node which I have, and as you can see, it has a path and it's moving from here to towards Earth. And if I play through, you'll see it has a very smooth motion for it. So here you can see it has a few keyframes here at the bottom, and if I open my curve editor, you'll see that all the curves are as smooth as I could make them to get the best output. Now there are a few main things that I took care of while creating it, so the movement is kind of dynamic. So first thing, I made sure that the object is like always moving at the same speed. And next thing is, in the beginning you can see the entire crosshairs are aligned from the bottom left to the top right, whereas in the end of the composite you will see that it's reversed from the top left to the bottom right. So it basically adds in like a fly-through feel. So once I created this, I had this camera here at the origin itself. So I just connected the input from the camera to the axis so that the camera is actually moving according to the axis. So basically what I can do is layer one axis on top of another, one taking care of movement, one taking care of rotation. So you can just layer one animation on top of another to create the final output. So this axis went ahead and gave me this motion, and to actually look at what exactly is happening in here, let me just go in and connect in my scene. So with this scene selected, I can go on, turn on my camera lock. So I'll go ahead and select my cam. So this is the camera I'm looking through, and by playing through, you'll see this is the results. So this is the kind of output which I'm looking at. I know exactly what I'm going to get. Now the thing is to add in something extra, so to just see how exactly it would look like in the end, I can go ahead and create my scanline rendering node here at the bottom. So this is the final output which you can see, and you can see it's quite high quality. You can see a lot of details. Even if I come forward, you can see there is a lot of details, but as soon as the Earth comes too close, you can see that you can actually make out the pixels in the clouds. You can actually make out the pixels on Earth itself. So I really did not want it to be like that. So for that reason, what I did is I added in some motion blur. And to add motion blur, all you need to do is go into your scanline rendering, and this is a way of adding in actual motion blur, not fake motion blur. So where you can do it is go into multi-sample in your scanline renderer and change the sample rate to something higher. So let's say I give in a sample rate of 2, and immediately you can see the entire image gets blurred, but you can see that there is immediately 2 duplicates of the same image. Basically it's being sampled twice. So to get in a better output, I can go ahead and increase the sample to, let's say, something like 6. So it gives me a smoother result. Of course, it does not work if there is a lot of motion blur, because in such a case, it will give you 6 different dots. So let's just look at these stars, for example. You can see that it can easily be made out that these are nothing but dots. So for that reason, you can't really use it as much as you want, because all the sharp edges will give you those cutting looks. So you would have to increase this value to a higher extent, so let's say around 30 or 40 to get the best looking output, whereas I did not really want to spend so much time behind creating motion blur. I just wanted it to look good enough. So for that reason, I left the samples at 1, and instead what I did is whatever output I'm getting here actually has actually, if you see here, this output itself, if I go into my motion channel and move my mouse around, you can see that here at the bottom that there is some values present here. So let me just go ahead and change the values here. Let's see if I can increase it. Okay, let me see. Okay, so as you can see, there is some values present in here. and these values are basically motion vectors. It's telling the computer how exactly the object itself is moving. So when I have these values, all I need to do is tell the computer to blur the image according to the movement of the pixels. So what I've done here is I've taken this node, which is known as a vector blur. So let me just disable this other node. So this is known as a vector blur, and what I've done is just enabled it. So what it does is gives me this additional motion blur in the background. So as you can see, it added in this motion blur just by the use of the way the pixels are moving within my final image itself. So as you can see, having this kind of ability to add in motion blur at a later time is a very big advantage. So once it is done, I added in a couple of grade nodes to do some color corrections, bring out a couple of lights, and then I wrote out the final image. So I'll go into what exactly I did here in a little bit more detail in a few minutes. Before that, let's actually look at these stars itself. And before I do, let me go ahead and increase the amount of motion blur. So I'll just, let's say, take it to 10. So as you can see, when there is a lot of motion blur, these stars, they kind of start losing their luster. They kind of go from white to something which is a bit darker. So here, when I take the multiply value to, let's say, around 80, you'll see that it's no longer white. They turn out gray. Whereas if you see when you take some pictures, or when you use your camera and you turn on the when you leave on the shutter for a very long time, light doesn't give you these streaks. Light gives you some very crisp, bright streaks. So this is kind of wrong. It's not giving the exact output which we need. So basically, to get the right output, what I did is I went into the star field. As you can see, there's a grade node applied to the star field. Within this grade node, what I've done is just decrease the gamma a little bit, and then the next step is in the emission node itself. As you can see, the emission is not set to 1 but it's set to 4. The reason for that is when I set it to a value higher than 1, it actually gives me float point values. So let's actually see that result first. So this is before the motion blur applied, and I'll take the emission value to back to 1. So as you can see, the entire background is darkened, and if I come to the brightest spot, you can see the maximum value here, the bottom is actually 1. So now if I take the emission value to 4, the brightest value is actually 4. So the reason this gamma node is being applied here is because this gamma takes the brightness and decreases it just a little bit, so that this increase is compensated by decreasing the gamma here. So let me just go ahead and decrease the gamma a little bit more so it's a little darker, and I'll take the emission to, let's say, something around 10. So when I go here to the brightest points, you can see the value here is telling me that the brightest point is actually 10 in number. And now if I come back to my vector blur, you can see that the lights have a bit more intensity to them. They are not as dark as they used to be. If I go ahead and take the emission down, you can see that they are darker, whereas when you apply motion blur to bright lights, they're not supposed to be like this. So by taking this value to a higher level, I was actually able to get something which is a bit more realistic in the real world. So this is the reason I apply the grade node and try to get as realistic a motion blur as possible. And of course, when you're applying vector blur, never blur it to this extent, because of course the result will be really bad. So as you can see, at a lower level, these light streaks look really good. They have this real smooth value to them. So let me just go ahead and decrease the value back to 1, which is the default. So you have these very bright specks of light which have slight motion blur applied, and they look really good. So I'll take back my emission down and increase my gamma back to 1.9. So I can see all the details. So if I just wanted the nebula to be a bit darker, I can just go ahead, take it down a little bit. Just depends on what look you're going for. So that is one thing I took care of to get proper motion blur, realistic motion blur. You can also do the same thing on Earth, because the light which is falling on Earth is from the sun, so basically you're supposed to have a very bright highlight, whereas I've just faked it. It's supposed to look good on cinema, not the real one, so I just made sure it looks good here. Now the next thing I've done here is actually add in some kind of glow onto the planet. So if you see here, I have some kind of a glow applied on Earth, and as you can see, it's brighter when it's facing the sun rather than when it's not facing the sun, whereas when it's in the darker region. So the way this is done is with the help of all these nodes here on the side. I'm not going to go too deep into these details, whereas I'm just going to give you an overall view about what exactly is happening in here. So let me go ahead and disable this. So this is the output which you are looking at, and this is the brightness which we have. So what I first did is, of course we know that our scene is being rendered over here, whereas I also added a new scanline renderer here at the top, and what this scanline rendering is doing is basically give me the render of Earth. So when it's giving me the render of Earth, I'm making sure that it's giving me more than what I want. So if I see this render here, you can see here that it's telling me it's 1280 720 here at the top. It's a simple HD footage. Actually the final resolution is 1980 1920 1080 full HD, whereas this output which I'm rendering here on the side is telling me that it is minus 20 pixels extra here on the sides. So the reason it's telling me that it's minus 20 extra is because in the scanline renderer you can see that it's over scanning by 20 pixels. So I'll tell you why that is required. Now once I have the scanline rendering, I went ahead and shuffled the nodes so that I have my alpha channel set into my RGB, and then I set an edge detect. So basically what edge detect does is it takes in the alpha channel and sees where exactly the edges of the object are. So if I go to my alpha channel, you can see I basically have an outline. Now once I have the outline, all I had to do is go ahead and dilate this outline. So basically I'm thickening or thinning the outline, and then I again went ahead and shuffled the alpha channel into RGB. The reason there are two shuffles is because the first shuffle is basically telling how the edge detect should work, and once the edge detect has worked, I'm shifting back the alpha channel again into RGB. So I have made sure I put in some annotations here on the side so you can understand what's happening. So next step was to apply some blur. So I blurred only the inside edge of the Earth. So I'm using the mask which I got in from Earth itself, the alpha mask, and I've applied it to blur over here on the edge, and I'm just trying to blur out the image itself. So once I have that one blurred, I graded it so it's a bit darker, so it's the inside region, and then I blurred the outer region so it's going outward, and then blurred both of them so there is no sharp edge. Okay, so there is this sharp edge on the corner, and I did not want it because it will give you a problem with motion blur, and I did not want to go ahead and correct that. So of course you can get rid of this error if you pre-multiply the alpha and all, but I really don't want to confuse you with that. So next, after this is done, I graded it so that it has perfect white and black values, and then graded it once more so that it has this blue color. Of course I could have used a single grade to do this, but I just wanted to be clear about what's happening instead of doing all of it in once. Next, once this is done, of course I wanted it to glow when the sun is there and not glow when the sun is not there. So I wanted some kind of control over that. So for this I went ahead and took this blur. I blurred the actual image of Earth which I'm getting in from the renderer itself, and I graded it so it's completely bright, and as you can see the shadow region is being cut off because basically I'm blurred it and the shadow region is gone, and because of the grading it's too dark to be seen. So now I'm just shuffling some nodes so that basically the dark region is the region with the sun falling on it is bright and the other region is dark, and now I'm just multiplying it on top so that the region where the sun's falling is brighter than the one where it's not. So this is what I had, and this is what I have. Simple alteration. Now the reason I had this overscan turned on here at the top is because if the overscan is turned off, this kind of edges is going to give you a problem. So let's just go to the point where Earth is just touching the corner. Okay, next frame. Okay, so as you can see, it's giving you some kind of an error. There's a dip here at the edge. The reason this dip exists is because when you're rendering only this final image, right? You're rendering only the final image and you can't actually see what's happening beyond. So the computer doesn't actually know that there is supposed to be an edge. So when it did all of this and created the edge, it doesn't have anything over here at the bottom, because of which when we have done all this blurring and created the final output, it's giving us this dip. So what I did is went ahead in the scan line and I overscanned the image itself. So by giving 0 overscan, I'm going to have the image cut off here at the edges, whereas it'll definitely look bad because it'll look like some kind of a camera effect. So for this region, I went ahead and overscanned it to a large degree so that I actually have an image even though there is nothing seen over there. So as you can see, it looks much better now because it's being overscanned and all the details exist. So now even if I go beyond, you can see the details over there are still existent and all of it as well. So as you can see, this is the amount of extra pixels you have. Of course, I don't really need that much, so I'll just decrease it, let's say 30 or probably even 20. So once I have this output, all I had to do is go ahead and screen it on top. So I have one region which is giving me this highlight, the final glow on Earth, and another one which is giving me Earth itself. And as because I'm using the same alpha channel as the Earth itself, it's exactly aligned. So all I did is screened it on top, and immediately it gives me a much better looking Earth. And I went ahead and applied motion blur on top of it because as you can see, there is a lot of pixelation, and once I apply motion blur, this pixelation is reduced a bit because the motion blur just blurs the image and gets rid of a lot of the details. Of course, you only need slight motion blur. My example which I've created here is very short, so there is a lot of fast movement, so of course there is a lot of motion blur, and as you can see, lots of details which I've added are actually being ignored now. So just do it in a way which you feel is right, whichever you feel would give you the best output. Now last thing which I would like to do is when the camera is flying through, I just want to have some kind of an asteroid or something right in the middle of the scene itself. So let me go ahead and disable this vector blur because it takes a lot of time to calculate, and I'll go ahead and shift over to the 3D view and turn off my camera lock so that I'm actually looking at my scene. So to create the asteroid, as you can see, the Earth and Moon are quite far apart and the camera moves through them. So I'm going to create an asteroid somewhere in between them. So to create the asteroid, I'm going to go ahead and duplicate the Moon. The reason I'm duplicating the Moon is because it's the easiest way of creating the asteroid directly. So let's see the Moon. The reason this Moon looks kind of half gone is because the alpha channel exists in here. So I'm going to make sure the output has only RGB in it. So as you can see, immediately there is no alpha and the Moon looks much better. Next thing I'm going to do is go ahead into the Moon properties and increase the rows and columns. And if you have observed through the video, the rows and columns on Earth are actually larger or more than on Moon because it is a larger sphere and I did not want it to have a bad silhouette. So let me just go ahead and actually increase it to, let's say, 100. So it has a lot of detail. And next thing I'm going to do is apply a modifier on this. So let's go ahead and 3D. I'm going to modify and I'm going to tell I want it to have displace geo applied. So I'm going to take this Moon and apply a displacement. And the displacement I'm going to apply is going to come in from this grade node. So as you can see, immediately that grade node is taking care of some displacements. So I can go ahead, I'll go ahead to pixelplanetemporium.com. I'll take in the bump texture which I had for Moon itself so that I can use that to displace the Moon texture. So I've just bought in the Moon bump image. So as you can see, there's the bump map which has been provided. All the craters and everything are dark in values and the elevations are bright in values. So if I just apply to my displace geo and just look at the output, you can see that it's working well. The only problem is the top ends and the bottom end are kind of being pinched. So if you want a good output, you might probably want to do this in Maya rather than in Nuke because the pinching is happening because of the UVs. So one thing you can do is just toggle this close top and close bottom on and off, so that the pinching is kind of reduced. I'm not sure why exactly it works, but it kind of works. So now with the displace geo, I can go ahead, scale this values till I get something which looks okay. And also to actually add in some extra details, or basically to create a rougher surface, I can go ahead, apply different kinds of modifiers. Like for example, I can tell let's say another displace geo on top of this, and for this displace geo, what I'll do is take a constant, let's say it's completely black, and I'll apply noise on top of this. Okay, so this noise is going to be my displacement map. As you can see, immediately it starts creating some details. Of course, the map which we have just created does not repeat. So as you can see, it's not something which repeats from both sides, so because of which you will have a seam in your object. So take care of how exactly you can work with it. Now once that is done, I can go ahead, scale it up or down, and try to get an output as best as possible. So I guess the best thing to do here would be to disconnect it and place it actually before the final pipe. So it's being displaced first, and then something is being applied. So we have something which looks very awkward right now. Of course, if we place it in the right way and the camera looks at only one region, then you can't really make out that it's really so low res or anything as such. So let me just go ahead and increase the resolution. My Nuke just crashed on me. So anyway, I have this asteroid, and it's been created. You can see it has a lot of details on it. So what I need to do is just place it in the path of the camera, so that when it's moving, it can actually go through this and give us a different looking output. So I'm just going to go ahead and take a output from here, connect it in there. Just let's go connect it back in there. So now if I go back to my scene, you can see the first thing is this object is actually being positioned exactly in the same place as our moon right now. So what I'll do is go ahead and transform this. So to transform it, all I need to do is apply a transform. Okay, sorry about that, it needs to be transform 3D. Okay, so I applied a transform node, and now with the transform node, you can see the handles are provided here at the center. I'm just going to go ahead and move it so that it's in the way of the camera when it's moving. So let me just lock into the cam. Just trying to position it such that it gives me a better looking output. Of course, I can go ahead to the moon file. I can zero out these values so the moon is exactly where it's supposed to be. And let's say here in the end, it's actually supposed to come on screen. So I'm just working with the screen space. So I'm just trying to rotate it so that you can't really see any of the seams and it looks okay. I'm just going to scale it up a little bit or down. Okay, so I just kept in the geometry over there, and if I go back to my scanline renderer and shift over to 2D, you'll see that immediately I have a 3D object set in there. So of course you can go ahead, bring in a 3D object from, let's say, of course don't bring in very high resolution meshes because your Nuke will crash. It is an awesome software, but of course it will still crash. So you can go ahead, sculpt in your geometry in ZBrush of course, and bring in some really detailed geo and try to work with it. So anyway, so this is what I wanted to show you today. This is an entire 3D introduction to Nuke. So we saw how to create simple objects, texture them. we saw how to create the simple texture, and then we saw how exactly you can go ahead and transform objects. We saw also how exactly we can go ahead and texture and shade our objects. We saw how to apply our diffuse, specular highlights and all such things. I showed you how to apply emission maps, and then also I went ahead and showed you how to use UV project so that you project your textures onto your objects. And then of course I went ahead and showed you a much more interesting composite, where I went ahead and created this composite with shadows and everything connected. This one is not working as of now because of the resolution. If the resolution is set right, it will start working again. Of course, I really don't want to go into it right now. So anyway, in the end, I showed you how to create this final Earth composite, and in the end we also added in that asteroid right next to Earth. So probably this is going to be Armageddon. Okay, so this is a way you can work with Nuke in 3D. So you create objects, or you bring in some objects and you create a composite like this, put in some lights, and you have a working model which you can render out. Now the last thing which I've shown you is how exactly you can apply motion blur to get the output, and also another way to get it is using the multi-sample. And let's see what exactly is remaining in 3D. Okay, the final thing, the one thing I've missed out, is how exactly would you bring in objects or render out objects or export objects from Nuke itself. So to do that, all you need to do is go into your 3D, and let me just do that here. If you go into your 3D, under geometry you have read geo and write geo, and exactly the way you have read and write nodes in Nuke, read geo brings in 3D geometry, FBX files or your OBJ files, and write geo writes them out. So this is the way you import and export 3D objects. So that is there. And of course you can go ahead, use Python, script in anything you want, script in some shaders or anything you want. And last thing I would like to mention, if you are using one of the latest versions of Nuke, under lights already you have a shadow tab, and by default you can just click on a check mark and you automatically have shadows. You don't actually have to go ahead and create shadows the way I did in this previous composite. So I really hope you understood this tutorial. I know this was a long one, it almost ran for 2 hours, but I really hope you understood something out of it. All the files that I've used, the ones that I can give, will be provided on the description, and those of which you can download off the internet, I'm going to provide you a link to them. So for now, this is all there is in the video. If you have any doubts, put them in the comments, and any feedback would always be welcome. So for this video, that's all there is. I'll see you in the next one.